To properly check a high-pressure sodium ballast with a multimeter and no applied voltage, you will need the following materials: a multimeter and the high-pressure sodium ballast itself. Safety precautions are paramount. Ensure that the ballast is disconnected from any power source and always use caution when handling electrical components. The procedure involves measuring continuity and also voltage output, although without applied voltage the voltage output test is limited to checking for open circuits. The first step is to measure continuity. This involves two main tests: the ballast capacitor test and the ballast coil test. For the ballast capacitor test, set the multimeter to the ohmmeter mode, which is indicated by the omega symbol. Place one probe on one terminal of the ballast capacitor and the other probe on the other terminal. A reading of infinite resistance, indicating an open circuit, suggests a healthy capacitor. Conversely, a reading of zero resistance, which indicates a short circuit, suggests a faulty capacitor. For the ballast coil test, again set the multimeter to the ohmmeter mode. Place one probe on each terminal of the ballast coils. Ballasts typically have 2 or 3 coils. A reading of low resistance, usually a few ohms, indicates a healthy coil. On the other hand, a reading of infinite resistance, representing an open circuit, or zero resistance, indicating a short circuit, signals a faulty coil. To measure voltage output, which is a limited test without applied voltage, you can perform an open circuit voltage test. Set the multimeter to the AC volts mode, indicated by volts with a tilde symbol. Connect one probe to each terminal of the ballast output, which are typically labeled as line and load. Rotate the ballast adjustment dial, if present, to its maximum setting. With no voltage applied, you won't get a voltage reading to indicate if it is above 100 volts AC. A reading significantly lower than this, with applied voltage, may indicate a faulty ballast, but without voltage, this test mainly confirms the absence of a short. Verify the wiring. Ensure that the ballast wiring is properly connected. Line voltage, such as 120 volts or 240 volts, should connect to the line terminals, and the lamp should connect to the load terminals. Keep in mind that the specific resistance and voltage readings can vary depending on the ballast model. Always refer to the manufacturer's specifications for exact values. If any of the tests indicate a fault, it is recommended to replace the ballast. This procedure provides an indication of the ballast condition. To ensure proper operation, it should be tested under actual operating conditions with voltage applied. To elaborate further on ballast testing, firstly, let's consider the capacitor test in greater detail. A capacitor's function within the ballast circuit is to store electrical energy, which it then releases to aid in starting the high-pressure sodium lamp and maintaining a stable current flow during operation. When you use an ohmmeter to check the capacitor, you are essentially assessing its ability to block the flow of direct current. A healthy capacitor should present a very high resistance, ideally infinite, because it is designed to prevent DC current from passing through it. If the ohmmeter shows a low resistance reading, this indicates that the capacitor's internal insulation has broken down, creating a short circuit. In practical terms, this means the capacitor can no longer store charge effectively and needs replacement. The absence of any resistance, indicated by a reading of 0 ohms, signifies a complete short, rendering the capacitor useless and potentially harmful to the ballast and lamp. Secondly, regarding the coil test, the ballast coils, also known as inductors or windings, are crucial for regulating the current flowing to the lamp. These coils are made of tightly wound wire, and their resistance should be very low, typically a few ohms. This low resistance is necessary to minimize energy loss as current passes through the coil. When testing the coil with an ohmmeter, a reading of infinite resistance suggests that the wire within the coil has broken, creating an open circuit. This break prevents current from flowing through the coil, effectively disabling the ballast. Conversely, a reading of 0 resistance points to a short circuit within the coil. This usually happens when the insulation between the wire windings deteriorates, causing the wires to touch each other. A shorted coil can draw excessive current, leading to overheating and potential damage to the ballast. Thirdly, the open circuit voltage test, while limited without applied voltage, is still valuable for identifying potential issues. When a ballast is functioning correctly, it should produce a specific voltage output even when no lamp is connected. This voltage is needed to initiate the arc within the high-pressure sodium lamp. By setting your multimeter to AC volts and connecting it to the ballast output terminals, you can measure this open circuit voltage. The expected voltage range varies depending on the ballast design, but it's typically above 100 volts AC. If the measured voltage is significantly lower than the specified value, it suggests a problem with the ballast's internal circuitry. However, without applied voltage, the absence of a voltage reading is not necessarily indicative of a faulty ballast, but rather a confirmation that it is not actively producing voltage, which is expected. Fourthly, wiring verification is an essential step in the troubleshooting process. Ensure that the ballast is correctly wired according to the manufacturer's instructions. The line voltage wires, which supply power to the ballast, should be connected to the designated line terminals. The wires that lead to the high-pressure sodium lamp should be connected to the load terminals. Incorrect wiring can cause the ballast to malfunction or even sustain damage. Always double-check the wiring diagram to confirm that all connections are correct and secure. Fifthly, it is important to consider the specific ballast model when interpreting test results. Different ballasts may have different resistance and voltage values. Always consult the manufacturer's specifications for the ballast you are testing to ensure accurate assessment. These specifications can usually be found in the ballast itself or in the product documentation. Sixthly, keep in mind that these tests provide only an indication of the ballast condition. A ballast may pass these tests, but still fail under actual operating conditions. To thoroughly assess the ballast's performance, it is best to test it with a high-pressure sodium lamp connected and powered on. This will allow you to observe the lamp's startup and operation, and to identify any issues that may not be apparent during static testing. Seventhly, when dealing with electrical components, safety should always be your top priority. Before working on any ballast, disconnect it from the power source to prevent electrical shock. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical circuits, it is best to consult a qualified electrician. Eighthly, if any of the tests indicate a fault, such as a shorted capacitor or coil, it is generally recommended to replace the entire ballast. Repairing ballast can be complex and may not be cost-effective. Replacing the ballast ensures that all components are in good working order and can prolong the lifespan of the high-pressure sodium lighting system. Ninthly, understanding the internal workings of an HPS ballast can aid in diagnosing problems. A typical HPS ballast consists of several key components, including a capacitor, an inductor or coil, and sometimes an igniter. The capacitor helps to regulate voltage and current, the inductor limits current and provides the high voltage pulse needed to start the lamp, and the igniter generates a high voltage spike to initiate the arc within the lamp. By understanding the function of each component, you can better interpret the test results and identify the source of the problem. Tenthly, documenting your findings is a good practice when troubleshooting electrical equipment. Keep a record of the test results, including resistance and voltage readings, and any observations you make. This information can be helpful when diagnosing similar problems in the future. Also, take photographs of the ballast and its wiring before disconnecting anything, as this can aid in reassembly. Continuing to build upon the knowledge of HPS ballasts and their testing, firstly, let's delve deeper into the types of multimeters suitable for this task. While a standard multimeter is generally sufficient, it is crucial to ensure that it is capable of measuring both alternating current volts and ohms accurately. A digital multimeter, or DMM, is often preferred over an analog meter due to its precision and ease of reading. Look for a multimeter with a clear display and a good reputation for accuracy. Additionally, consider the multimeter's safety rating, which indicates its ability to withstand voltage surges and protect the user from electrical shock. Secondly, the capacitor's role in the HPS ballast circuit warrants further explanation. The capacitor serves two primary functions. Firstly, it acts as a power factor correction component, improving the efficiency of the ballast by reducing the reactive power drawn from the electrical supply. Secondly, it helps to stabilize the current flowing to the lamp, preventing fluctuations that can shorten its lifespan. A faulty capacitor can lead to several issues, including reduced lamp brightness, flickering, and premature lamp failure. In some cases, a failing capacitor can also cause the ballast to overheat. Thirdly, the inductor, or coil, is a critical component for current regulation. It limits the amount of current flowing to the lamp, preventing it from drawing excessive current and burning out. The inductor also plays a role in generating the high voltage pulse needed to start the lamp. When testing the inductor, pay close attention to the resistance reading. A slightly higher than expected resistance may indicate a partial break in the winding, which could still allow the lamp to operate but at a reduced performance level. A significantly higher resistance, or an open circuit, indicates a complete break in the winding, preventing the lamp from starting. Fourthly, the igniter, if present, is responsible for generating the high voltage spike needed to initiate the arc within the high-pressure sodium lamp. Some ballasts have an integrated igniter, while others use an external igniter. If the igniter is faulty, the lamp may fail to start or may start intermittently. Testing the igniter typically requires specialized equipment, but you can often visually inspect it for signs of damage such as cracks or burns. Fifthly, when testing the ballast, it is important to consider the ambient temperature. Extreme temperatures can affect the resistance and voltage readings. It is best to test the ballast at room temperature for accurate results. Also, avoid testing the ballast in humid environments, as moisture can interfere with the readings. Sixthly, if you suspect a problem with the ballast, but the tests are inconclusive, consider performing a visual inspection. Look for any signs of damage, such as cracked or burned components, loose wires, or corrosion. A visual inspection can often reveal hidden problems that may not be apparent during electrical testing. Seventhly, when replacing a ballast, it is important to choose a replacement that is compatible with the existing lighting system. Ensure that the replacement ballast has the same voltage and wattage ratings as the original ballast. Also, consider the ballast type, such as magnetic or electronic, and choose a replacement that matches the original type. Using an incompatible ballast can damage the lamp or the lighting fixture. Eighthly, after replacing the ballast, it is a good practice to test the entire lighting system to ensure that it is functioning properly. Check the lamp's startup and operation, and monitor the ballast for any signs of overheating or malfunction. Also, measure the voltage and current at the lamp terminals to verify that they are within the specified range. Ninthly, regular maintenance can help to prolong the lifespan of HPS lighting systems. Clean the lamp and fixture regularly to remove dust and debris. Also, inspect the ballast and wiring for any signs of damage or wear. Replace any worn or damaged components promptly to prevent further problems. Tenthly, consider upgrading to a more energy-efficient lighting system. LED lighting systems offer several advantages over HPS systems, including lower energy consumption, longer lifespan, and better light quality. While the initial cost of LED systems may be higher, the long-term savings can be significant.